now that we have the definitions down of statements and negations and what the difference is between them and how to negate something and the symbols, let's take a look at something that's specific called quantified statements and their negations. So this is a little bit more complex. That's why it's important to get good notes and to keep them so that you have them. What is a quantified statement? So let's first look at that. So with a quantified statement, this is something that requires specific words, okay? Specific words, and those words have a value. So we're going to say it contains the words all, some, no, or none. And no or none is really what sounds grammatically correct, okay? So contains the word all, some, no, or none. Think of that as like those multiple choice questions where it's all of the above, none of the above, that sort of thing. Okay, so let's have a couple examples because I think that might clarify things a little bit. So here's our example. All poets are writers. That means if you are a poet, you are also a writer. Notice it does not interchange. You can't say all writers are poets because that's not true. So you have to keep things in the order that they are. You also have, let's see here, we'll do this. No people have died from taking a math class. Okay, and if you need to, go ahead and pause it there so you've got the information. So those are some examples. And what I like to do is to underline. So there's my quantifier and here's my quantifier. So I'm looking for those words in particular because once I have those words, it really determines what I do with it. So let's look at it from a graphic standpoint of what that means. So all. It makes sense that if I have poets on the inside, right? So let's say my group A is poets and my group B is writers. So what I'm saying is that there is this container called writers. And this container is one big giant circle. But within that circle, there are poets. Okay, so inside that circle are poets. That would be the equivalent of, let's do a couple other examples that might make sense. Let's say we have all FHS athletes, but then there's a portion of them which are cross-country. Okay, so not all athletes are cross-country runners, but all cross-country runners are FHS athletes. Well, I should say FHS cross-country. All right, so we've got that visual. Let's go ahead and define it down here and do an equivalent statement. So I'm just going to kind of keep going down that column. So if I want to describe this, I would say all A are B. All A are B. Meaning that every member of the set of A also belongs to the set of B. Now there's a thing called an equivalent statement. So an equivalent statement is another way to say the same thing. Because sometimes a straightforward statement may not be as clear as we need, so we need to look at the equivalent. And likewise, sometimes you're given the equivalent and the straightforward one is a little bit easier. Okay, so the equivalent statement of all A are B is this. There are no A that are not B. There are no A that are not B. There are no A that are not B. Meaning, I can't find a single one of these A members that's outside of the circle of B members. All of them are in there. So there are none of them that are not part of that. That's what we mean by that equivalent statement. And I'm going to do equivalent statements throughout the whole entire thing. So in fact, what I may do is just go ahead and put a line here so we know that the equivalent statement is going to kind of come below. And then we're going to have a couple things going on here, so I'm going to divide that. And we're going to end up dividing this as well. So I'm going to put a couple extra lines in there. All right, let's look at some, and then we'll negate all of them together. So here we had A and B. A was yellow, so we'll go ahead and put that same color in there. Okay, so we had that yellow here. So we have all the members of A. And then B, of course, was that green. So this is our B, right? And the difference here is that there's a little bit outside that's not a part of that membership, right? But then you have this inside stuff, and this inside stuff is both. So you've got some A that are just A, they're not members of group B. You've got some Bs that are just B and not member of group A. And then you have this inside where some of them, meaning whatever value you have, are both A and B. So there's a couple ways to say this. So the first way we're going to take a look at is we're going to say some A are not B. Some A are not B. So that means that this piece of the pie right here, those suckers are not a part of B whatsoever. These ones are a part of B. Okay? There's another way to say it. You could say some A are B. So that would be this population right here. The stuff that's in the center. All of that, you have parts of your A that are also part of B. So this one right here really talks about this outside little Pac-Man guy. And then this one right here is this portion. So there's two ways to describe that group of A. The stuff that's not B and the stuff that is B. All right, now let's look at the equivalent statements. These are kind of funky, so that's why we want to take good notes, because you'll really need to have this written down. Not all A are B. Not all A are B. That's what that equivalent statement says. So not all of these have B. So it's talking about this population. And let's go ahead and do the equivalent statement of this one. There exists at least one A that is B. So that equivalent statement is basically talking about this center population, right? That there's an overlap, and I don't know how many is in there, but there's at least one, right? Because the graphs overlap. So again, that's talking about this one, and this was our original statement. All right, one last one. Let's go ahead and take a look at A, none, or no. So we've got A, which is our yellow one again. So we're going to go ahead and color that in. So we have A. And then we have our group B, and B is this one here, right? So there's none of my A is part of B whatsoever. It's not overlapping. And so that's what I'm going to call it. No A are B. No A are B. So there's no overlap. What we could also say is an equivalent statement that all A, oops, let me get that, are not B. So there's not a single one of my A's that is part of the membership of B. So that's my description there. All right, so now we're going to move down to negating this. And once we negate it, there's going to be something for you guys to go ahead and try. And I'm going to give you some time to get that done. And I'll put that check in a different video so that you've got it. All right, let's look at negating quantitative. So let's go back to all, right? All A are B, or there are no A that are not B. Well, the way that we take care of all is by using the word some for my negation. You would think it would be no, but that's a little bit too far extreme, right? So what we're basically doing is we're taking the pieces that are overlapping and we're pulling A out to the point where we have that overlap. So before you get to none, you get to this portion where they're overlapping, and that would be some. So my negation for all would be some A are not B. Some A are not B, because I'm starting to pull them apart. And when I start pulling them apart and I get that overlap, some of those A are not contained in the B. All right, let's look at negating some. Do you see here that we have a connection between, let me change this color here real quick. Some A are not B. Do you see the connection between these two? Okay, so some A are not B. You see that direct connection. So what do you think the negation of some might be? Right here. So all A are B. That would be your negation for that type of sum. Now we also have a sum that's talking about this overlap period. So what we just did was this part. Now what we want to do is tackle this inside part. Well, we know that there's an overlap there. We are magically going to have that same overlap. So this is going to go here, and this is going to go here. So my negation on this is going to be no A are B. And this negation is going to be some A are B. And the reason why we can negate that is because if you take two things that are not connected and you start moving them together, then all of a sudden you have an overlap, and there are some of the A's that are now part of B. So that's where we get that statement. Okay. So this is a whole lot of information, but you need this to be able to decipher what you've got. So let's do the first one together, and then I'm going to stop the video and have you go ahead and check yourself. So all dogs go to heaven. I'm going to underline my my quantifier, and it says, oh, it says circle. Let me circle that. And then I'm going to write the negation statement of each. So if I have all dogs go to heaven, all dogs go to heaven, all dogs go to heaven is right here. So my negation is going to be this. Some dogs are not going to heaven. That would be heartbreaking. So some dogs are not going to heaven. Okay, so that's how you're going to start. Go ahead and circle your quantified statements, and then use this chart up here, right? You want to see which relationship is it. Is it all, some, or no? And then go down here to check out what your negation statement would be. So I'm going to go ahead and conclude this here, and then we'll come back to check those answers.